In the final video in structure 1, the ideal gas equation is what we're going to be looking at. So yeah, we're going to be looking at the ideal gas equation followed by some practice problems. And then yeah, as always, before you get going, make sure you download your free PDF so you can be making your own notes as you follow along. So let's get going. So the ideal gas equation, and here it is. So it combines everything to do with gases. So we're going to look at what makes it up and the units. So the units are the really important thing here. So pressure, so yeah, pressure, P stands for pressure, and pressure has to be in pascals. Then V is for volume, and volume yeah, has to be in meters cubed. Then yeah, N stands for moles, R is the gas constant. So we've talked about constants quite a lot in the last few videos, and that constant is the gas constant, and this is the value here, 8.31. So yeah, both the equation and this number here are in the data booklet, so you don't need to worry about remembering those. So there we go. And then yeah, finally, temperature is still in Kelvin. So all of these units are pretty straightforward, apart from maybe volume being in meters cubed. And this is not in the data booklet, so you need to remember how you can convert to meters cubed, to decimeters cubed, and then also to centimeters cubed. So a lot of the time in the question, things are going to be quoted in centimeters cubed, but you need to convert the number to meters cubed for it to work in the equation. Okay, so let's put this into practice as we look at some practice problems. So here is our first one. So how many moles of an ideal gas do you have if it has a volume of 700 centimeters cubed at a temperature of 200 degrees Celsius and it is at a pressure of 300 kilopascals? So here we have our equation. So it's, yeah, you just basically want to work through each value that you have, make sure it's in the right unit, and then put it into your equation. So yeah, so pressure, pressure, here we go, was at 300 kilopascals. So yeah, we've multiplied that by 1000 to then get it into pascals. Then yeah, volume, so volume is in centimeters cubed. So we're dividing by 1,000,000 to get our volume in meters cubed. Number of moles is what we're trying to find out. The gas constant is always going to be 8.31, and then yeah, other reminder, you can find that in the data booklet if you can't remember that. And our final thing is temperature. So yeah, we need to convert 200 degrees Celsius into 200 degrees, into Kelvin, which is 473 Kelvin. So I have just rearranged the equation. So it is now equal to number of moles, and then yeah, we just put the numbers in, which will then give us our answer. So let's work through the numbers backwards. So yeah, here's our temperature value, the gas constant, then our volume, and the, oh dear, I want to get rid of that, and the pressure. So put all those numbers into your calculator, and then as if by magic, you're going to get your answer. And then, yeah, so we've kind of got numbers to 3 significant figures in the question. So our answer is to 3 significant figures. So there we go, very straightforward. So now let's take it up a level. Let's go to level 2. So, and this, yeah, this is specifically mentioned in your syllabus. So this is why I went through this example here. So yeah, being able to calculate the molar mass of a gas from some data. So in our question here, we have a gas that has a density of 1.24 grams per decimeters cubed, and it's given us a temperature, so 0 degrees Celsius and 100 kilopascals. And then yeah, what is the molar mass? So a bit of physics sneaking in, but yeah, so density is mass divided by volume. But if we decide our volume is going to be 1 decimeter cubed, then we will be able to find out how many moles are in 1 decimeter cubed. And then once we know the number of moles, we've got the mass, and that will be the mass in decimeters cubed. We can then use this equation, which we should be familiar with, to calculate the MR. So let's look at the numbers. So yeah, first step is using PV equals nRT, so that's just what we've done in the last example. So again, we're converting all of the numbers, so we can quickly go through that. So yeah, so converting our pressure to pascals, volume to meters cubed, again we're solving for number of moles. 8.31 is still the gas constant, and then yeah, we've got our temperature of 273 degrees Kelvin. Then I haven't written it out, but yeah, quite straightforward. Just put the numbers into the equation, and we are getting our number of moles. So now we know the number of moles, and we know the mass. We are putting it into our equation here. So mass divided by the number of moles, and then that is going to give us our final answer of 28.1 grams per mole. Very straightforward, I hope. I think the only tricky thing with this is yeah, kind of making this link here and then making sure you're using a volume of 1 decimeter cubed. Okay, so quite a quick one there, but I hope you enjoyed it. And then yeah, if you found this useful, please do share this with all of your chemistry friends, and yeah, like and subscribe for more future chemistry videos. And we're going to be moving on to some trickier topics now, so make sure you hit that subscribe button so you get a notification for when we start those. All right, thank you as always for watching, and catch you in the next one. Ciao, ciao.